There is a rock sitting in the middle of Australia that has been studied by geologists, archaeologists, physicists, and climate scientists for decades. And the more carefully they look at it, the less it fits the explanations they arrived with. Uluru rises 348 meters above the flat red desert that surrounds it on every side. It is 9.4 kilometers around its base. It is not the largest rock formation in Australia, and it is not the oldest, and it is not the most geologically unusual in purely technical terms. But it is the one that keeps producing findings that do not fit neatly into existing frameworks, and it is the one that the traditional owners of this land have always described in terms that modern science is only now beginning to find ways to understand.
There is a rock sitting in the middle of Australia that has been studied by geologists, archaeologists, physicists, and climate scientists for decades. And the more carefully they look at it, the less it fits the explanations they arrived with. Uluru rises 348 meters above the flat red desert that surrounds it on every side. It is 9.4 kilometers around its base. It is not the largest rock formation in Australia, and it is not the oldest, and it is not the most geologically unusual in purely technical terms. But it is the one that keeps producing findings that do not fit neatly into existing frameworks, and it is the one that the traditional owners of this land have always described in terms that modern science is only now beginning to find ways to understand. What researchers have found in the last 20 years at Uluru has not been adequately reported in mainstream media. The findings are real, documented, and published in peer-reviewed literature. The problem is not that the science is hidden. The problem is that when you put the findings together in a single place, the picture they produce is significantly more remarkable than any individual paper suggests. This is that picture. If you are new here, this channel covers Australian history and ancient country that most people were never properly taught. Subscribe now and let me know in the comments below what you already knew about Uluru before watching this video today. Let us start with the geology. Because the geology alone, before you add anything else, is more extraordinary than most people realize. Uluru is made of arkose, a type of coarse-grained sandstone that forms when granite weathers and the resulting sediment is compressed over time under enormous pressure. The arkose that makes up Uluru was deposited approximately 550 million years ago, during a period known as the Cambrian, when the region that is now Central Australia sat at the bottom of a vast inland sea. The sediment accumulated in layers on the seafloor, was compressed into rock, and then underwent a process that geologists are still debating the full details of. Because here is where the standard explanation becomes interesting. Uluru does not sit flat on the landscape the way sedimentary rock normally does. The rock layers at Uluru are tilted almost vertically, at an angle of between 80 and 90 degrees from horizontal. This means that what you see when you look at the surface of Uluru is not the top of the formation. You are looking at the edge of it. The actual top of the rock layers is pointing sideways into the ground. The full extent of Uluru underground is estimated by geologists at approximately 6 kilometers below the surface. 6 kilometers. The rock you can see at the surface, the 348 meters that rises above the desert plain and catches the light at sunset in colors that shift from orange to deep red to almost purple as the angle changes, that visible portion represents only a small fraction of the total formation. The vast majority of Uluru is underground, extending downward into the earth in a near-vertical column of ancient compressed sediment that reaches depths human drilling equipment has never come close to penetrating at this site. And the tilting itself. Geologists describe it as the result of tectonic forces that folded and compressed the rock during a mountain-building event that occurred several 100 million years ago. The mountains that formed in that event have long since eroded away. Uluru and the nearby formation of Tjukurpa are what remain, the roots of a mountain range that no longer exists above the surface. What this means is that Uluru is, in a very literal geological sense, the exposed root of something much larger that has been lost to time. The visible part of a structure that extends far deeper into the earth than it reaches above it. And the forces that shaped it compressed the rock so completely that the arkose at Uluru is among the hardest and most durable of its type found anywhere in Australia. This is partly why it has survived while everything around it eroded. Uluru is geologically exceptional not because it appeared, but because it remained. Now let us talk about what scientists have actually found in recent decades, because this is where the story becomes genuinely remarkable. The first significant modern scientific finding at Uluru came from acoustic research conducted in the early 2000s. Researchers studying the site's physical properties documented that Uluru produces measurable sound. Not from wind moving over the surface, and not from thermal expansion and contraction of the rock in the daily temperature cycle, both of which produce sounds at many rock formations and are well understood. Uluru produces low-frequency acoustic emissions from within the rock itself. These emissions occur most strongly at certain times of day and certain times of year. They are not random. They follow patterns that correspond to specific environmental conditions, particularly the transition between temperature states at dawn and dusk, and the period following rainfall events when water penetrates the rock surface and interacts with the internal structure of the formation. The researchers who documented these emissions described them as physically consistent with the piezoelectric properties of certain crystalline minerals present in the Arcos. When pressure is applied to these minerals, they generate an electrical charge, and the release of that charge under changing physical conditions produces measurable acoustic output. The effect is real, documented, and physically explicable. What the research also noted, in a finding that received considerably less attention than the basic acoustic discovery, was that the frequency range of the emissions overlapped with ranges that have measurable effects on human neurological function. Very low-frequency sound, in the range produced by Uluru under certain conditions, has been documented in separate research contexts to produce alterations in human perception and emotional state, not through any mechanism that requires invoking anything beyond straightforward physics, but through the direct physical effect of low-frequency sound waves on the nervous system. People who spend extended time near Uluru, particularly in the hours around dawn and dusk, frequently report experiences of heightened emotional sensitivity, a sense of deep calm, or conversely a sense of profound awe that feels different in quality from ordinary aesthetic appreciation. For a long time these reports were treated as subjective responses to an impressive landscape. The acoustic research suggests there may be a straightforwardly physical component to them. The Anangu people, the traditional custodians of Uluru and the surrounding desert country, have always understood that Uluru has a voice. This is not a metaphor in Anangu tradition. The sounds that come from the rock are real. They are described in specific terms in Tjukurpa, the law and knowledge system that governs Anangu understanding of country, and they are associated with specific times, conditions, and meanings. Modern acoustic research did not discover something new. It produced instruments capable of measuring something that had been known and described at this site for an unknown number of generations. The second major area of scientific finding at Uluru involves the rock's surface chemistry and biological ecosystem. Uluru's surface is home to one of the most complex biological crusts found anywhere in an arid environment on the planet. The dark surface coloration that most visitors notice and attribute simply to the rock itself is in fact a living system, a biological skin of cyanobacteria, algae, lichen, and fungi that has developed across the surface of the Arcos over an enormous period of time. This biological crust is not unique to Uluru. Biocrusts of this type are found in arid environments globally, but the one at Uluru has characteristics that distinguish it from comparable formations elsewhere. Research conducted by teams from the University of Adelaide and published in the 2010s documented that the biological crust at Uluru has an unusual thickness and structural complexity compared to biocrusts studied at similar arid zone rock formations in other parts of Australia and globally. The community of organisms present is more diverse. The interactions between the organisms are more elaborate. And the crust shows evidence of very long-term stable development, meaning it has been building and developing continuously over a span of time that is difficult to estimate precisely but is measured in thousands of years at minimum. This biological system plays a significant role in the hydrology of the rock's surface. The crust acts as a sponge during rainfall events, absorbing water and releasing it slowly rather than allowing it to run off immediately. This is partly why the waterfalls that cascade down Uluru's surface during heavy rain are so dramatic. The rock is not simply shedding water. The biological system on its surface is managing water flow in a way that maintains moisture in the rock surface environment long after the rain has stopped. The waterholes at the base of Uluru, the permanent and semi-permanent pools that collect at the base of the rock's drainage channels, are among the most significant features of the site from an ecological perspective. They have maintained reliable water in one of the driest landscapes on Earth for a period that extends far beyond the historical record. Animal tracks, plant communities, and the evidence of continuous human use at these specific locations tell a story of a resource so dependable that it has been a center of life in the surrounding desert for an incomprehensible length of time. The third area of scientific finding, and the one that has produced the most significant revision of previous understanding, involves the age and continuity of human presence at Uluru. For most of the 20th century, the standard archaeological estimate of human presence in the Uluru region placed it at around 10,000 years. This estimate was based on the oldest material then available from excavations in the region. It was a working figure, always understood to be a minimum rather than an absolute date, but it became the number most commonly cited and most widely understood as representing the age of the human connection to this site. That number has been revised substantially. Research published in the last 20 years, drawing on improved dating techniques including optically stimulated luminescence dating of sediment layers and the analysis of ancient DNA recovered from archaeological sites across the broader region, has pushed the earliest confirmed dates of human presence in Central Australia back to at least 50,000 years and possibly significantly further. 50,000 years of continuous human presence at a site means something that is genuinely difficult to fully absorb. It means the Anangu relationship with Uluru predates the European presence in Australia by a factor of roughly 250. It means this site was significant, understood, used, and described in accumulated knowledge long before any of the civilizations of the ancient world that European culture tends to treat as the foundation of human history had begun. It means that the Tjukurpa, the knowledge system through which Anangu understanding of Uluru is transmitted across generations, represents one of the longest continuously maintained bodies of knowledge about a specific place that exists anywhere on the planet. And what that knowledge contains, when researchers and Anangu knowledge holders have worked together to understand specific elements of it, has repeatedly turned out to describe physical realities about the site that were not confirmed by Western science until instruments capable of measuring them were developed. The acoustic properties of the rock, described in Tjukurpa in terms of the rock's voice and the conditions under which it speaks most clearly, were confirmed by acoustic measurement equipment in the 2000s. The hydrological behavior of the surface, the way water moves across the rock face and collects at specific points, is described in Tjukurpa in detail that has been confirmed by geological survey. The locations of reliable water sources, the seasonal patterns of plant availability, the movement of animal populations through the landscape, all of it encoded in knowledge that has been maintained and transmitted here for 50,000 years. This is not coincidence. And it is not, as some earlier researchers suggested, simply practical observation accumulated over time and dressed in ceremonial form. It is a sophisticated knowledge system that has preserved accurate information about a complex physical environment across a span of time that has no parallel in any other human knowledge tradition currently documented. The fourth area of finding involves what has been discovered about the internal structure of Uluru through remote sensing and geophysical survey technology applied to the site in recent decades. Ground-penetrating radar surveys and seismic reflection studies conducted as part of broader geological investigations of the region have produced images of the internal structure of the Uluru Formation that were not previously available. These surveys have confirmed the near-vertical orientation of the rock layers and the depth of the formation, and they have also identified structural features within the rock that were not apparent from surface observation alone. The interior of Uluru is not uniform. The geological forces that tilted and compressed the formation created zones of different density and different mineral composition within the rock. These internal variations create what geologists describe as structural heterogeneity, which in practical terms means that the physical properties of the rock vary significantly from one zone to another within the formation as a whole. The acoustic emissions, the piezoelectric effects, the thermal behavior of the surface, all of these are influenced by the internal structure of the rock in ways that are only now beginning to be mapped. What the surveys have also confirmed is the presence of cave systems and void spaces within the base of the formation, not at the visible surface level but within the rock itself at and below the level of the surrounding desert plain. These voids are not accessible from the surface under current conditions, and they have not been explored. Their extent and characteristics are known only through the indirect imaging of the geophysical surveys. The Anangu have always described Uluru as containing places that exist within it rather than on it. Specific locations within the rock associated with specific ancestral beings and events, accessible in ways that go beyond simple physical entry into a cave. The geophysical surveys have confirmed that the interior of the formation is structurally complex in ways that were previously unknown to science. The correspondence between what the surveys found and what traditional knowledge has always described about the rock's interior is another instance of the same pattern that appears repeatedly when Western scientific methods are applied carefully to a site that indigenous knowledge has been describing accurately for thousands of years. The fifth significant area of finding involves Uluru's role in the broader landscape and the implications of new research into what scientists now call songline geography. The Anangu and other Aboriginal nations across the continent navigate and understand country through a system of routes, landmarks, and associated knowledge known in English as songlines, though the translation captures only part of what the concept encompasses. Songlines connect significant sites across enormous distances, encoding knowledge about navigation, water sources, seasonal resources, and the relationships between different parts of country in a form that can be transmitted, remembered, and used across generations. Uluru sits at an intersection of songlines that connect it to significant sites across a vast area of the Australian continent. In Anangu understanding, it is not an isolated landmark. It is a node in a network. Researchers working in the emerging field of archaeological landscape analysis have begun mapping the relationships between significant sites across Aboriginal Australia using a combination of traditional knowledge shared by custodians, archaeological survey data, and remote sensing technology. What this work is revealing is that the songline network is not simply a cultural construct. It corresponds to real geographical relationships between sites that share physical characteristics, water availability, ecological significance, and in some cases geological connections that were not apparent until survey technology made them visible. Uluru's position in this network corresponds to a location of genuine geographical significance. It sits within a region of Central Australia where geological, hydrological, and ecological factors converge in ways that made it a reliable and critical resource center in the desert landscape. The songlines that connect it to other sites trace routes across the landscape that follow, with remarkable consistency, the most viable paths through terrain that would otherwise be impassable for traveling people carrying minimal equipment. This is not mystical. It is applied geographical knowledge of a landscape accumulated across 50,000 years of direct experience. The songlines work because they encode real information about real geography, maintained in a form that could be transmitted without writing, across a span of time and through a continuity of practice that has no equivalent anywhere else in the documented human record. The picture that emerges when you put all of these findings together is not of a single dramatic discovery. It is something more significant than that. It is a picture of a site that has been known and understood at a level of genuine depth for longer than most of human civilization has existed. A site whose physical properties, which are real, measurable, and in some cases genuinely unusual, have been accurately described in traditional knowledge for generations without the intervention of the instruments that Western science needed to confirm them. A site whose significance to the people who have always cared for it was never in question and is now, incrementally and sometimes reluctantly, being confirmed by the same scientific disciplines that spent most of the 20th century declining to take that significance seriously. What scientists have found at Uluru has not produced a single headline discovery that can be summarized in a sentence. It has produced a slowly accumulating body of confirmation, finding by finding, that the Anangu understanding of this place was right. Not approximately right. Not culturally interesting while being scientifically incomplete. Right in ways that required 50,000 years of continuous attention to a specific piece of country to develop and maintain. That is the finding. And it is more remarkable than any single dramatic discovery could be. Because it means that the most sophisticated knowledge of Uluru that exists is not in any university. It is not in any published paper. It is in the Tjukurpa, maintained and transmitted by the Anangu people, across an unbroken chain of attention to this place that stretches back further than any other documented human relationship with any single location on Earth. The scientists who have spent careers studying Uluru with the most advanced instruments available will tell you that the most important thing they have learned is how much the traditional owners already knew. And the traditional owners will tell you that the rock itself has been saying the same thing for a very long time. To anyone who was listening, if this changed how you think about Uluru, let me know in the comments below and subscribe for more Australian history that most people were never properly taught.